So this is joint work with various people in the room, Ram, Alair, Abby. Did Abby come in? Yes. Yeah. Katrina, who's ex of this parish and is now accumulating universities in terms of, she's with us and Queensland and now Exeter. And her involvement is important because it's going to define the location, and then other people from UQ as well. So, what's this about? I should mention funders. So partly funded through SEED, but also through the marine biodiversity hubs. In fact, an old one of the NERP we were funded through rather than NEST. But so this is a little project which basically used some money that was left over from a bigger project, and we set ourselves 3 objectives. One is to get some spatially explicit values from marine ecosystems, and what I mean by values is things which come out of a non-market valuation study. Just to anticipate a question. So it had that objective. We wanted to explore this either HII or actually what we've done is called integrated choice experiments to deal with this problem of when you have choice experiments with large numbers of attributes. And typically, if you have large numbers of attributes, people say you need to start slicing them out and compressing them. So, but there's a technique which lets you address that. And then the third objective was to start exploring this idea of preferences versus production functions in discrete choice experiments, which was an old idea. It's been around, well, an old idea, 10 years. It's been 10 years that this idea, and it's finally starting to come to fruition. So hopefully we're going to be able to show you all those 3. So the first one. And I'm going to try to work our way through those 3 ideas. So first one is just context. Why Morten Bay? Because Katrina, as part of her postdoc, was based in Brisbane and was looking at wanting to work on a valuation project. And so Morten Bay, which is just off Brisbane, was chosen as being a useful, appropriate location. It has not 6/7 of the world's marine turtle, but 6 out of 7 species of the marine turtles. It has nursing sharks, dugongs, sort of icon species. It's quite large. It has recreation uses in there, rec fishing, has industry, has commercial fishing. So it's got a nice contested use of that landscape, of that seascape. And why do we want to get these spatially explicit values? Well, for a marine spatial optimization model. So this is the sort of thing which Katrina does in trying to work out optimally where you ought to place marine reserves. And typically the way that's done, in terms of the way the ecologists would do that, is you get ecological data, spatially explicit, about habitat or species presence and absence, and then try to work out, say, minimizing the area that you put into reserves in order to achieve a certain target. I want 10% of different habitats under protection. How do I identify where there should be protection in order to achieve that? Then with various other constraints around it. What people have now also starting to do in that literature is say, well, we shouldn't just be thinking about trying to minimize area. We should think about opportunity costs of land or sea space areas being allocated. We should probably be trying to achieve the ecological outcomes, but at the same time then, subject to that, maximizing commercial fisheries or recreational fishing benefits. So recognizing that there may be sort of economic costs associated with protection and trying to achieve the target, but now layering in these other factors, so the economic components to it. So there are, she and the guys from UQ have been building this, and this is sort of the thing which pops out. This is sort of an early version, not yet complete, but you have pixel zones which are allocated, which are sort of identified square kilometer zones, I think. And it sort of optimizes and puts different areas under different levels of protection. So green, marine national park, blue, general use. So this one is trying to meet the targets, which is 10% of habitat, of each of the habitats under protection, but then at the same time maximizes commercial fishing benefits. So it puts them into space, and if you change the definition of what you're trying to do, say change is commercial fishing and rec fishing, you get a slightly different picture. But there are other values associated with marine ecosystems. There's all these non-market existence values, not held by people who fish or either commercially or recreationally, but they may just be from the population of Brisbane. they actually value having these ecosystems protected. So can we actually start to introduce these sort of classic non-market existence values, non-use values into this type of model? So we'd like to see if we can do that. And that's why we want to get some spatially explicit existence values so that we can see what happens when we pop those into the model. So what we want to do is some spatially values for these spatially explicit assets. The assets are the ecosystem types. We're not going to actually, when we do the valuation, ask people to value stuff in space. We're going to ask them to value different ecosystems, then we know where they are in space. So we're not going to ask them to think about protecting this bit, this bit. We're going to ask them about protecting an ecosystem type. Then we know where it is, and we can, in that way, generate a spatially explicit value. First big challenge, which happened there, not here, thankfully. The ecologists would define 16 habitats. That's too many for us to work with. Katrina beat them around the head until they agreed what 4 habitat categories would be. I think they didn't like the idea of, because everything's valuable and shouldn't be aggregated together, this implies substitution. But basically we come down to these, we want to work with 4. So vegetated habitats, the outer bay, loose substrate, which is sort of sandy bottoms, and hard substrate, which is a fairly small area. So those have got different ecological characteristics. So for our purposes, we're going to work with these 4 habitat categories. We're going to run a contingent valuation study. So we're going to ask people basically to value putting these different ecosystems under protection. So we need to describe to them what's happening out there. This is stuff which, well, some of it people may interact with, but there's other things which they don't. So the marine environment is quite an interesting one to do valuation on, because typically people don't, they can't, well, they might swim on the edges of it, but unless you're diving, whatever, you don't really know what's happening down at the bottom of the sea. So we're having to describe why you might care about what's happening in these ecosystems. So this is just examples. The outer bay, it contains things that you might, the sort of icon species or threats, depending on how you view these things. We talk about the hard substrate. What does that mean? Well, it looks like that and has these characteristics. So they get, in the standard way, we describe to them the attributes so they understand what's going on. And then, jumping straight into this, what you could easily think of doing is setting up a choice experiment where, well, we describe to them what the current situation is, the level of protection of those ecosystems that are currently under protection, 18, 16, 15, 18. We tell them the total size of those ecosystems. They've seen maps as well, but in the choice sets, we tell them the size of those ecosystems. So hard substrates are really a little one. And then we offer them the classic options, option 1, option 2, different policy scenarios. We say we could change the level of protection up or down, and we might change the costs to you. So we're going to, a classic non-market valuation study. So we can get out of this, potentially we can start seeing how people value different protection of ecosystems. If that's all we wanted to do, we'd stop there and we'd run this choice set and off we'd go. But we have this second objective, which is that we want to use this setup basically as an exploration for how you might deal with large numbers of attributes. So we've deliberately made that one quite simple. That would be a perfect little study to run. But now we're going to deliberately make it difficult for ourselves by looking at or setting up a problem where we have a large number of attributes. So when the focus groups were being run, I think there were at least 4 focus groups run. So this is a picture of the whiteboard with all the stickies that people put on in terms of trying to get them to elicit what it is they value when they think about marine parks and what. Unfortunately, so this was done obviously before we did the first bit. Thankfully, ecological stuff came out about protected areas and I can't read them now, but protection of species. So those are all good. They want that. But then at the same time, what was coming up quite strongly were these sort of recreational aesthetics. So we asked them generically, what do you value about protecting Morten Bay? So recreational areas, well maintained walking trails, water quality, pristine waters were all popping up as other attributes that you might value. So now we could sort of reframe our problem as saying if you had to think about managing the bay as a whole for multiple outcomes, so not just the ecological ones, but we're now going to extend the mix, we might then also add in, because people care about this, we're going to add in some recreational aesthetic attributes. So we have 4 of those. One is beach closure, as in at times the bay is closed because of algal blooms and so on. so they can't swim. Beach cleanliness, which came up, as in how much litter are you seeing. Walking trails, they wanted access, so we've described them, the level of walking trails in terms of access, and then how we might then increase that, making it clear they wouldn't be put onto environmentally sensitive areas, so we're not having that trade-off. And then signage, something which is sort of slightly left field, but out of the focus groups, they really wanted to have good signage around the bay, both to tell them what was there, but also how you should behave. So it's like a management outcome. They valued that. So that gives us an extra 4 attributes. So obviously what you could do, and this is quite straightforward, isn't it? As in, you can simply add in 8 attributes. We now have 8 attributes in the choice set plus the cost. We have our 4 ecological ones. We've added in the 4 recreational ones. You could just give that to people, and obviously you guys, intelligent people, could easily process this choice. You're given either the current situation, or you can go for those 2. You can look down the attribute levels. You can do the trade-offs in terms of weightings. So this is the high number of attributes problems. Actually, typically people start saying, people can't do this. Sort of around 9, 10 attributes is the point where people start to think that people have cognitive problems, particularly when they're unusual, unfamiliar attributes. So we've designed ourselves into a corner.
When you say 9, 10, is that also a function of the number of options you give them to?
Yes, so in terms of cognitive load, it builds with numbers of options, number of attributes, number of alternatives, the levels, number of levels, and so on. So, yeah, but for us at the moment, we're interested in what happens as we blow up the number of attributes. So typically, you wouldn't suggest putting that in front of people as a survey, because it's just too hard. So then you go back into the literature and say, well, how do people value complex goods? These things we've got these multiple attributes. How do people process that? And there's a literature out there which suggests that what they do is you take attributes, those are our 8, and they convert them into what are known as constructs. So this is quite easy to do because the way we've done it, but the first 4 are an ecological construct, the second 4 are this sort of aesthetic recreational construct. And the idea is that people sort of do a sequential, an integrated hierarchical process of take attributes, convert them or evaluate them on the basis of their constructs, then convert the constructs into some sort of view of what the utility is of the marine area, and then they make choices. So rather than processing the 8 down into utility, that it's done sequentially. People take attributes, work out what does this look like in terms of an environmental outcome, a recreational outcome, how do I trade off those 2 to give me some idea of how I'm going to make choices. And this is what's known as hierarchical information integration, this idea that you actually process this way in sequences, and whether it's HII or integrated choice just depends slightly on the way you design the experiment. But this is seen as being a way of dealing with these large attribute sets. So this has been applied in transport and health in some, but as far as we're aware, not being used in environmental resource economics. So this was just, thought we could have a go at this. So how do you do it? Well, what you do is you construct sub-experiments. And you take one of the constructs and just represent it as an index. So in this version, this has got the 4 environmental attributes set in, and it's got the recreational experience defined simply as a score, 1 out of 10, or from 1 to 10. So we're just going to pop a number in there. So now we've solved, in some sense, our complexity problems. We've gone from 8, we've gone down to 6, and this one is much easier to process now. It's just a single number. So that is one sub-experiment. And there's the recreational experience index, scored 1 out of 10. Okay, well, wait, hold it, Ben. Wait for it. Here comes the environmental condition. Your question will be answered in a minute. You can then do a second sub-experiment whereby you've got the 4 recreational attributes and you've got 1 environmental condition. Again, scored 1 out of, from 1 to 10. What's the score? What's the value going to be for environmental condition? So obviously in this one, currently not very good, but option 2 gives you a fabulous environmental condition, maximum that you could possibly expect. So you can just run those sub-experiments, put subsamples through each of those data sets, and then you can estimate a single model. So the idea is that you can concatenate or stack the data to get a single model. People have actually seen either that and responded to that or that.
Sorry, did you say people either see
one or the other? So you either answer the one which has got the recreational index or the one with the environmental index, because basically these are otherwise, well, you have limitations on how many questions that. What do you do in terms of estimation now? Well, you estimate it as if they've seen that, i.e., I have a data set now which has got both responses which include a recreational experience and the 4 ecological outcomes, an environmental condition and the 4 ecological and the 4 recreational outcomes, and the cost. Everybody sees the cost, and they see either one of those other blocks. But we can treat this now as if this is a single data set that's been generated. So when we estimate it, we're going to potentially be able to get access to the values of the underlying elements of recreation and environment. And at the same time, almost as a byproduct, a nuisance possibly, measures for these aggregates, the environmental condition and the recreational experience. So you can combine those two together. So I'll answer what I think is Ben's question. But what meaning can be given to the constructs?
Exactly.
Thank you.
So you turned something that was complicated into something that's meaningless.
Yes. It is on this slide, but the next slides which follow, perhaps not surprisingly, I anticipated not only the question, but I have an answer ready for you. What a surprise. That was, what meaning can be given to the constructs? Because people in the audience will say that this thing is meaningless. What does it mean to have a recreational experience that goes from 1 to 10? What does a 10 mean? It's an ecological, environmental condition. So this is sort of the classic schoolboy error of doing non-market evaluation studies, where you put attributes in which have no meaning. They have a number, but they have no real sort of solid meaning to anything. What are you going to do with those? Well, what's the process? Well, this is the integrated choice experiments have an answer to that. They basically train people, or they have these rating activities. So this is before we get anywhere near presenting them with a choice set. You ask them a whole series of questions about these attributes. So this is for the people who are going to see the environmental construct. So they're going to see in their DCE an environmental construct that is 1 to 10. Before we get to that, we're going to tell them about the environmental condition of the bay. We're going to give them the pre-information about vegetated habitats. And then we're going to say, well, if you had to think about the best combination of these habitats, and these are the levels they're going to see later, 10, 18, 25, 30, which of those would be best for you? And not important. So now potentially you're just going to tell us, well, is this thing important? And if they have a choice, what level would they like to see? No trade-offs. Nothing about budgets. No trade-offs between environment and recreation. This is just, what do you think you would like to see in terms of ecological outcomes? So they do that for each of the 4 environmental attributes. And then we say, right, you've told us what your best possible combination. In this example here, they told us it was max for all of them. So that combination there is generated on the fly in the survey, 30, 30, 30, 30. And what you see there is what you said earlier in the previous questions. And then we show them 2 other options and say, well, just score those. That's a 10. What's that? Give me a number between, could be 1, it could be 10. Presume it's going to be less than 10 because we're getting some decrement in values. Just give us a number as to what you think. An 8, is that an 8? Is that a 7? Give us a number. They did 4 of those. And that's obviously binary, so we're getting for both option 1 and option 2, they're doing that. And then at the end we say, okay, thinking about what you've just done about the bay, scoring it, okay, we now have this idea of an index 1 to 10. What do you think the current environmental condition of Morten Bay is? So on this scale, which was where do you think we are? So this person's given us a 4. they obviously know about or thinking about in terms of those attribute levels. So what they think that generates for them. So when they see this, the choice experiment, and up pops the current situation, that number is what they've told us is what they think is the current situation. So it's on the fly in the online survey. That is done dynamically, pivoted off what they've actually said.
That's customised for every respondent.
Yeah.
I have a question. That looks like a setup, like you paid Ben.
No. He's very, very, very predictable. Okay, so what you can do is you can treat these little experiments as if there's each sub-experiment as if they're just a separate study. No. So we did this. We did an ecological construct one. So this is people who they're looking at the recreational attributes and cost, and they've got an eco-index turning up in there. They have a status quo which they can opt out, and this is just done with a random parameter on the status quo, so we can allow for the fact that people have different views as to whether they want change or not. So that on itself looks quite nice. Cost is negative, which is always a good thing. They don't like spending money for no purpose. And then they don't like beach closures. They like it clean. They like having these walking trails. They like signage. They like having an ecological index coming up. So that works quite nicely. We started with 500, 400, it got down to 400 because some people were going in through with really fast responses, and some who were always choosing the status quo, and then when we debriefed them said, I don't think I should have to make these choices. So they're sort of the classic protest people who were just taken out. You can do it with the recreational construct. So here you've got the recreational index, positive. They like having improved recreational condition. Now what we're seeing are these are the percentages of these ecosystems that are under protection. And in this one, well, I'll start at the top. The cost is negative. That's good. In this one, there was something interesting happening in terms of levels. There were 4 levels for each of these. And for loose, for example, this is the sandy bottoms, for all the 4 levels, it looked like a linear progression. They wanted more of at all levels. That was true for loose, it was true for hard. So this loose level 4 is a dummy variable which is the attribute at level 4, not significant. Hard, level 4, not significant. The outer bay, yes, we get this negative effect of it having a level 4 level for the attribute. What does that mean? If you just plotted the utility, this is the percentage of the outer bay that's under protection. This is the implied utility. It's linear until you hit 25%, and then it's flat. So we're getting this very strong decreasing marginal return to protection, i.e. going from 25 to 30% does not increase utility. They're still happy to have 30%, but no more happy than they were at 25%. So a very strong decreasing marginal. And that isn't me just drawing a straight line. That is literally, it's basically flattened. Then the vegetative one, exactly the same thing is turning up. We get this linear effect, positive effect for vegetation levels. We get to hit level 4, which is again 30%. You get this big negative coefficient, which is just enough basically to flatten that utility out completely. Again, we're getting complete decreasing marginal utility. They don't want to go beyond 25%. You can concatenate the data, and it turns out this is a bit boring because particularly if you just notice that the cost coefficients in these 2 samples were incredibly close. So they were responding quite consistently. So when you concatenate the 2 data sets and estimate it as one, almost nothing changes. The cost coefficient is about the average of the 2 other cost coefficients. But essentially, we can do this. We can have large numbers of attributes. We can split them into these sets. We can train people up on the attribute levels, on the index levels. We can get them to do separate surveys. We can join the data together. We can get a single model which includes values that are attached to both the ecological levels but also the recreational ones. So that's good. Now, the classic question, is your journey really necessary? Because, well, could you just use the full design? As in, you could just put the full design in front of them. The claim was, you can't process this. The reason for doing ICE is to get to be able to solve this problem of too many attributes. So could we just put that in front of people? how, as in you've seen, you've had done vast numbers of these surveys before. Anybody reckon this is a sensible thing to do in terms of a research plan? You know, you'd think not. It's just, surely that's too hard. So, but we just put through another 500 people through a design where they saw the description of the attributes, then they got the choice sets again. And the little dears did this. So this is the combination. They processed this really well, which was so depressing. When the point when you want it to fail, they came through for us. And you can see, as in the cost coefficient, it looks about the same. Things are sort of significant and of the same orders of magnitude. It's easier if you compare them side by side. So that's the where there's difference, as in the ICE, as in hard didn't have. No, it's not us, unless that's. Is it across the way? Well, let's assume it's across the way until we. ICE wasn't significant in terms of this sort of plateau. It is in the full data set. When you do the recreational attributes, this is just me splitting it into 2 bits. There's something happening with beach, as in the ICE when we do them separately. These is negative, as in they don't like beach closures. In the full one, something's happened that's gone positive. And on the ICE, we had a progression. They liked more walkways. In the full one, they haven't. So although it's sort of looking similar, it's not quite. Looking at the debriefs, so this is percentages. Did you consider all the attributes? I think now we're struggling. Now we're trying to say, okay, statistically it's the same, but surely they're doing something different. Did you consider all the attributes? Same across all 3 designs. Did you find the scenarios confusing or particularly difficult to answer? Yeah, 29, 25%. Time for completion, were they skipping through really fast or really slow as a result of this big set? No. Do we have to clean more people out for protests and fast completion? No.
I think it's interesting that more people found the...
Yeah. So that's just an interesting outcome. So this is, okay, why? Anyway. So back to our first objective. We wanted to get some spatially explicit values. So just to remind you of that, we've got an ICE, an integrated model. We can do something with that. We could work out willingness to pays. So what you can do is just work out per percentage point of protection and what they're willing to pay per year for 5 years. So this is just standard, just part words. $4.53 for 5 years to get an extra percentage point into vegetative protection. For Katrina, what she wants is that's per kilometre, because you're going to have these little pixels, cells. We need to know what how people value not a percentage change, but an area. So now these values change because they're of really quite different areas. So although the hard substrate looks like it has the lowest value, when you work it up and into a per kilometre squared value, it's actually really much being valued more. So those numbers. And then what you want to do is you want to take this up, aggregate it from a per person to the population of Greater Brisbane, which we'll say is our group, and then we want to convert it into an annual payment. So we annualize the 5 years, we net present valued the 5 years, then we annualize and you get these numbers. So this is the value of putting a square kilometre of vegetated sea into protection in thousands of dollars per square kilometre. So this is for an aggregate population. These numbers are large, that's huge, technically, huge. So they seem to be really big, the numbers, the values we're getting out.
Doesn't that, sort of some marginality here, above 30%?
Okay, this is for the changes up to the point when you hit the plateau. Okay. So implications for the spatial planning model. What we can do, the way we'd use this is the way that Avi was doing for in the paper in biological conservation, is that what you can do is you can start saying we should be lifting those targets, because these values all exceed the value you're going to get from commercial or rec fishing. So, if you ever have a choice between having an area that's dedicated to commercial fishing or put it into protection, the population of Brisbane would rather it went in under protection. So we don't have any nasty little trade-offs here. We can and no sort of questions about, well, you know, is it marginal that this should be in or out? Basically, this is saying it should be in. So this hasn't been done yet. We'll just rerun that spatial optimization model, but just lift the level of protection from 10% up to 25 or 30. We can't go beyond 30. We never asked people whether they valued at 50% protection. So we'll just, but that's to come. Okay, 5 minutes to the last one. This is quick. So the last one was this idea of preferences versus production functions. So we're trying to squeeze as much as we can out of this little study. So this goes back to, not quite 10 years, a paper that we did for the program that would preceded NERP, which preceded NESP. So this was about whether, when you estimated a choice experiment, whether you were identifying preferences or production functions. What do we mean by that? Well, this was built off, as in standing on the shoulders of giants, really. This goes back to work by Becker, Michael, and then Stigler and Becker about how people form preferences. And if we look at that theory, this was what they called the new theory of consumer behavior. What they argued was that what households did was valued Z goods. So they valued these aggregates. And so if you take the example of meat demand, as in people don't value meat or chicken or beef, what they value is nutrition. And when they go and buy beef or chicken in a shop, what they're doing is they're buying an input into a production function. And when you buy that input, what you do is you combine it with human capital, material capital, goods like ovens or microwaves, and time, and then you produce out of that this Z good, which is nutrition. So what they're arguing is that the observed community demand is, which we normally measure in the market, is actually a derived demand for inputs into a household production function. And you can think of that both for Z goods, you can think of it for health, you can think of it for shelter, as in what you're doing when you're buying a house. So this is actually, I think, a really neat way of thinking about the way that the world works. You buy stuff not for themselves, you buy it because they're an input into a production function. How does that link to what we're doing? What's the mapping? Well, why does that matter? Well, just replace the word Z goods with our constructs. So they had these sort of high-level things like nutrition or health or protection. Instead of thinking of those high-level Z goods, just replace the term Z goods with our idea of constructs, an ecological construct which is about recreation or about environment. And then replace the idea of a household production function with the idea of a subjective, or in the case of the environmental one, a subjective ecological production function. So in the Becker theory, people have household production functions where they buy inputs which they use to construct into goods, which are Z goods. In our translation, what people are doing is they want to have these ecological interventions in the system because they think that those will be used, or when they are implemented, they will generate outputs into these constructs. So I don't want to, as in marine protection in itself isn't what I want. I want marine protection because it generates for me a functioning, well-functioning ecosystem. And it's the ecosystem I value, and I want to have the inputs into that to deliver it for me. They're subjective because these are normal people. Do you really understand how those things connect together to generate what you want? So this is particularly valuable, I think, when you've got uncertainty about how this system works. You could do the same thing with the recreational one, but that's more obvious that if what you are buying is more access, you know what access means, and access means you can go and walk nearer the sea. So in that sense, the subjectivity of the recreational production function is probably going to be less than the ecological one. But we can have this idea. And then, so then the question is, well, what does this all mean? Well, when people are answering this question, we're getting coefficients, parameters estimated out, of which we're calling utilities, about their preferences when they're looking at this. Are they really revealing to you what their preferences are, or are they also revealing a mixture of their production function and their preferences? So are they looking at this and thinking, if I can get 25% of the vegetated habitat, that generates some notion, it produces some notion of a well-functioning Morten Bay ecosystem. If I have 10% of the hard substrates, that's in some sense is going to be is not going to generate a good ecological outcome for me. So this is why this idea of what are we seeing when we estimate those models, are they reflecting the way they think the system works to generate what they value, or are they actually saying that they value, because we just interpret them as being preferences, whereas actually they might be, it's a mixture of preferences and production functions. Possibly, this is the theory. This is the conjecture, sorry. Okay, what have we done on this? Well, the rating questions, the things that sort of happened at the start, which are like the training, we think that that provides a basis for estimating those production functions. It had nothing to do with trade-offs. It just said, you know, how would you score this? What's the outcome that you would get by having this level of protection? So that looks as if we might be able to estimate those as production functions. So we haven't really got very far on this. You'll be pleased to know. It means I can stop talking. But at the moment, do we have any evidence of what's going on? Well, what's quite interesting is that we get evidence of those plateau effects in the ecological attributes, that they want certain types of attributes up to a certain point, and then they stop wanting them. But there's absolutely no evidence of any diminishing margin utility when you look at the construct. So you can do the same thing with the construct, the 1 to 10, and say, well, you know, do they like going, you know, up to 8, and then we get to 9, that's not much, and 10, it sort of comes off. No evidence of that whatsoever. So they're just linearly wanting more ecological outcome construct, which is sort of contrary to the evidence we're getting when they look at the ecological attributes, which suggests that they're stopping. I've nearly finished. I think I literally have one slide left. So is that an indication that there's some sort of divergence between how they see this ecological construct outcome being generated and how they value them? So we've got to dig into that some more, but that's the idea. Oh, look at that.